Hello people, in this video I would like to talk about Bode diagrams, especially about the magnitude diagrams of Bode plots. Of course I will maybe brief introduction to phase diagrams, but first of all, since I think students will more get asked in exams about magnitude diagrams, I just want to give you some points, give some information about those Bode diagrams so that in exams you will not struggle. I think drawing Bode diagram is one of the easiest topics to me, but I think there is a, let's say, polemic around it, like students struggle on that. So I hope this video helps you to get over those Bode diagrams. So first of all, we will have different examples to make you understand different kind of effects in Bode diagram. So let's just go. So first of all, let's define a G1 as equals 10 over s plus 10, all right? And with blue marker, we will have G2 or G2s 100 over s plus 10, all right? So I just changed the gain value, okay? 10 and 100. And let's draw here, or let's first do other things. So first of all, if you want to draw a line, you should know what the initial point is, right? You should first define your first initial point. In order to do that, how you can find your Bode magnitude plot's first value. So guys, first of all, we need to make, in the denominator, we should make this 10 only 1, okay? So we should do something in this denominator to make it like s over something plus 1, okay? I think you just figure out the point. We will just divide the denominator on this value to get plus 1 here, okay? Let's do it. So we divide all the parts with 10 and s over 10 plus 1. So we get our 1 here, right? But after that, I can get rid of those 10s, which is here in the numerator and the denominator. So I will have lastly 1 over s over 10 plus 1, okay? This is G1s. Let's do the same procedure for G2. G2s equals 100 over 10 times s over 10 plus 1. This 0 goes, so we will have G2s equals 10 s over 10 plus 1. Let's draw the Bode magnitude diagram. So first, let's write down our y-axis, right? And we will have our x-axis. Let's demonstrate how you can find your initial value. So guys, if you are sure in denominator, by the way, you can have multiple poles, so you can have like s over 10 plus 1 times s over 50 plus 1. It goes and goes and on, and you have a value at the denominator. There will be no constants. There should be no more gains in denominator, and you will have alone here a value. By the way, you can have also zeros, like 1 times s plus, let's say, 100. This is also valid, but not in this example. So if you are sure you have only one value at the denominator, we just do 20 log that value, 1, equals, in this example, log 1 is equal to 0, and 20 times 0 is 0, right? We will have 0. So our first point is 0, okay? The red transfer functions start from 0, okay? By the way, let's label our axis and indicate those points. This is decibels and this is frequency. And let's say this is 10 to the power of 4, 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0, maybe it's not important, 10 to the power of 0, okay? And let's move on. So take a look at this transfer function. We have a pole, or we may have a pole at 10, right? Think like that. Of course, if you plug 10 into S, it's not 0, but think like this. When you draw those Bode diagrams, just think over this value at the denominator, S plus something. So that something is your pole, okay? Let's say like that, it's a pole. So I start from 0, I go without a slope, without a, and let's say we just do a certain line. And after that, when we reach out to 10, since we have a pole, poles make our diagram go down, okay? Since it lies on the denominator, and if you had a 0, which we will do in next examples, it will make our system, the Bode diagram, go up, okay? Because it's at the top. So you will go down, down, down. Let's say we went into 10 to the power of 2, okay? You may ask, what is the value after a certain time? So since this is, so we were at 10 and now we were at 100. Since this is logarithmic, it goes like 10 times 10 times. So it is 10, this is 100, this is 1,000. It goes by the intervals 10 and 10, okay? And also, the slope of this line is 20 decibels per decade, okay? It goes down or up 20 decibels per decade. It is a single effect of a pole, or 0 is 20 minus or plus 20 decibels per decade, okay? Single effect, a single pole or a single 0. So we went a decade from 10 to 100, and this is minus 20 decibels per decade. So if you had start from 0, this is going to be minus 20, right? Minus 20 decibels. Okay, this was simple. Now we have our other example, the same transfer function but a different gain, different value. So it's going to be 20 log 10, which is log 10 is equal to 1. It's going to be 20, right? Let's do 20 here. So we will start from 20. We will go until 10, and after 10, we will go down until 100, okay? By the way, don't get confused. It goes down until infinity. There is no stopping it. It goes until infinity. Also this one, they go down. But I just indicate the value so that you can understand the idea better. Since we went from 10 to 100 a decade, this also has minus 20 decibels per decade. It will reach out to 0. The idea of this example is to show you how you can find your initial value, the gain, and the effect of the gain into your Bode magnitude diagrams, okay? So let's have another example which has a 0 in it, okay? G3S equals, so let's say we have here S plus 10 over S plus 50. Okay, let's do it like this. So first, I should leave these constants as 1, right? So I just divide all the parts with the constant value. So 10 s to the power of 10 plus 1 over 50 s over 50 plus 1, okay? So those sides go, and we will have 0.2 times s over 10 plus 1 over 50, sorry, hold on, s over 50 plus 1. Okay, this is our G3. All right, I think that's simple. So let's draw it. For let's see, I can, let's see how I can just calculate if I have a calculator here, but I'm not sure. Yeah, let's quickly find our value. Hold on. All right, never mind. So just close it. 20 log 10, 20 times log 10 of 0.2, right? We had 0.2. Minus 13, or let's say minus 14, okay? For convenience, let's say minus 14. So it will start from minus 14, okay? This is decibels, and this is frequency. And let's do 10 to 4, 3, 2, 1. And here 0, okay? And since I think you all figured out, we have 50 somewhere here, okay? Or let's make those values larger so you can understand the idea. Hold on, this is going to be 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0, okay? You will see why I did this. So we will start from minus 14, okay? And until 10 or 0, until 10, it will go a straight line. It went as a straight line. Since we have a 0 at the point 10, it will start to go upwards. And when it reaches out to a 0.5, by the way, we will not find the exact value, okay? We won't find, but here our slope is 20 decibels per decade, and at the frequency 50, there's a pole, right? So pole will make it go down, but since we had a 20 decibels per decade, a plus value, it will just get rid of it and it will go as a straight line until infinity, okay? And here naturally our slope is 0 decibels per decade. There is no change because we had a 0 here, but zero's effect is worn off by the effect of this pole here at 50. All right, that's the whole issue. Piece of cake. And there is only one more thing I would like to show you, because it may be sometimes confusing. I don't think it is, but let's cover this up. So we have a G4, okay, equals S plus 10, no, S plus 100. Here we have S plus 10 times S plus 200, S plus 300. This is not a valid example, but just making you understand how these slopes change, I do this. So let's go into G4S equals 100 times S over 100 plus 1, all right? And the bottom, we will have 10 times 200 times 300 S over 10 plus 1, S over 200 plus 1, and S over 300 plus 1. I know my handwriting is too bad, but I want to be quick. So it's going to be something like 10. I'm trying to get the value, the DC value. So it will be 10 over 200 times 300, okay? And this goes, so it's 1 over, is it 6,000? 1 over 6,000. So this is a really low value, but it's not important. But how we can figure that out? Hold on. 20 log 1 over 6,000. Okay, it's minus 75. Okay, It's a bad value, but not important. Let's go. So we have minus 75. Okay, we will draw. So what I did is 20 log 1 over 6,000, which equals minus 75 decibels. All right, I found my initial value. Right? So let's write it down to not forget. We have a 0 at 100, and we have poles at 10, 200, and 300. All right. Okay, I think this place is enough to draw it. So this is my y-axis, and this is my x-axis. This is decibels, this is frequency. So let's say here we have minus 75, okay, and here is 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and it goes until 10 to the power of 3. So and let's say here is 200, and here we have 300. Okay, those are in the places of our poles. Okay, so first we have, so let's draw. So we have nothing until 10, but at 10 we have a pole. Okay, it will go down until 100, right? At 100 you have a 0. So this slope was 20 decibels per decade. Here we will get rid of that slope and we will have 0, but until 200. At 200 we have a pole, right? So again we will go down until 300, and at 300 we will have one more pole. So here 0, here minus 20 decibels per decade. But be careful, at 300 we have one more pole. So let me have a space here. After that point it will go strictly down, okay, with the value of minus 40 decibel per decade. So we just add, okay, let's just formalize quickly. 1 0 affects the system like 20 decibel per decade. All right, if it's 2 zeros, it's something cumulative. We have 40 decibels per decade. It also works for like poles. One pole, minus 20 decibels per decade. Let's say 3 poles, it will be minus 40 decibels per decade. All right, the same thing. We started here with 0 because there was nothing until then, and we just made a slope with minus 20 decibel per decade. All right, but at 100 we had a 0, which will make our slope go high. But since we had minus 20, it was just 0, right? 0. And then at 200 we had our pole go down with minus 20, and at 300 we have one more pole, which made us go minus 40 decibels per decade. All right, I think that's it. We covered so many topics of Bode magnitude plots, but if you have more questions, please write them in the comments so I can make a new video about this. I'm planning to make another video about solving examples of magnitude plots, or I will just introduce you the phase plots and do some examples after that. So overall, I hope this video was helpful to you, and I hope you understood the idea behind Bode magnitude diagrams. And let's see you at the next video. So catch you up later, and goodbye.